Hey guys, the objective for this video is to do a numerical solution for two-way drainage, an abrupt load change, and beta equaling 1/2. So in terms of our flowchart, this is what we're looking at. We're looking at an abrupt change in load, beta equaling 1/2, and two-way drainage. So this is the branch we're on. So the first thing we need to do is set the change in Z and the change in time such that we get beta equals 1/2, because beta equals 1/2 is a much easier formula to work with. So we know that beta is equal to CV times change in time on change in Z squared. So we need to set change in time, and that's in years, and change in Z in meters. We're keeping consistent with our units such that we get beta equals 1/2. So you don't want to be dividing your 8 meters into stupid values. So a nice value might be 2 meters. And we also don't want to get too many sub-layers, because that means we're going to get too many rows in our table, which we don't want. We want to have, obviously more rows is more accurate, but just when we're doing questions, we want to keep our rows kind of small just so it doesn't take too long to do these questions. So a change in Z might be 2 meters, which means that a change in time to make this equals 1/2 would be 1 year. So if we were to work this out, we would get 2 by 1 on 2 squared, which would be 1/2. So you guys would just have to play around with the values you want to do to get beta equals 1/2. Sometimes in a question they might specify a change in time or a change in Z, and then you're going to have to work out the other value. But for this one we can just make it all up. So now we'd come and draw up our table. So we have time, sigma or Q or P, it's just the pressure, the applied load at any time, the change in stress, so the change in stress from each increment of time, and then we would divide our layer by 2.